Math 3, Unit 9, Section 7, solving exponential equations without common bases. So this is just a review of vocabulary at the top. Remember that the small number is your base in logarithmic form, but we call it it's a regular size number in exponential form. The logarithm is equal to an exponent because we call a logarithm a what power function. So this means what power do you raise 5 to get 125, and the exponent would be 3. So 5 to the third power. And the 125 we call the answer. So we had problems in the last section where we got the same logarithm on each side, like log base 6 here. So we were able to set x over 7 equal to 9 because the log base 6 matched. On these problems, we're not going to have values that match like that. So we're just going to be solving for x, which if you notice on this first page, every single x is in the exponent position. And that's what logarithms are used for, is when you have a variable that's in an exponent, the only way to solve for it is to use a logarithm, unless you have a really nice, neat number here. Like if this 30 would be a 49, we would know that x equals 2. But since it's in between 2 powers of 7, so 7 to the first power and 7 squared, so 7 to the first power is 7, 7 squared is 49, we know 30 is between those values. So we can approximate right now that x is somewhere between 1 and 2, but if we want to find the exact answer, we need to use this change of base theorem to find the answer on our calculator. So some calculators, you can type in, log base 7 of 30, and it'll give you the answer. But a lot of calculators won't allow you to do that. So let's see if ours does. No. So if you type in log, it doesn't show a base right here. And you know that if it doesn't show the base, it's automatically base 10. So we can change to base 10 by using this equation up here. So log base c of a converts to log base 10 of a over log base 10 of c. And then we get to use the calculator for it to answer. So for this first equation, I just want to get the exponent down first, and then I can start to solve. So in order to get the exponent down, I have to change to logarithmic form. So log, the base is the number that's being raised to the exponent. The answer, log base 7 of 30, equals the exponent. Log base 7 of 30 equals the exponent. So we've now solved for x. This is an exact answer for x, written as an expression. So write your answer in terms of logarithm in 2 different ways. This is one way. And then the second way would be to write it by changing the base. So we're going to get ready to change the base anyway, so we're going to write it this way. So if you notice, the c is in place of the 7, so that's going to be log of 7 on the bottom. And the a is where the 30 is, so it's going to be log of 30 in the numerator. So this is x equals log of 30 over log of 7. These are both base 10, and we know that because the base is not written down. So we're going to do log of 30 divided by log of 7. That's going to give us the exact answer, and we expect the exact answer to be somewhere between 1 and 2. So when you get an answer that is between 1 and 2, that's a good sign. So this is 1.74786. Let's see where we round to. Evaluate your answer using a scientific calculator and round your answer to the thousandths place, which is 3 decimal places. So that would be, first of all, we have our 2 different ways to write our answer, 1, 2. And then our approximation using the calculator is 1.748. And all we did was type in log of 30 and divide it by log of 7 to get that number. So you have 3 answers here. Answer in terms of logs, 2 different ways, and then an answer rounded to the thousandths place. Let's try the next one. So again, we're going to change from exponential to logarithmic form. So my base is this number 8. The answer is 74, and that's equal to the exponent of 2x. This is not solved for x yet, so you need to make sure to isolate x, which means divide by 2. So one of my answers actually, let's go back. Because we can't divide the 74 and the 2, we're going to evaluate this first. So we're going to write our answer 2 different ways, but we're going to leave it as 2x instead of solving for x. It'll just help us before the end. Okay, so that's one way. The second way would be 2x equals the change of base. So that would be log of 74 over log of 8. Same thing, log of your answer over log of your base. Written 2 different ways, and then we're going to approximate it. 2x is log of 74 divided by log of 8, 2.0698, which means 2.07. And now we're going to divide by 2 at the end, because otherwise our answer gets pretty messy. All right, so I'm going to leave it all on the calculator, but you can also just divide 2.07 divided by 2, and you get 1.035. All right, next one. So I want to make sure to isolate my base and the exponent before I keep going. So right now, this 5 is extra. So I'm going to divide by 5 on each side, which gives me 2 to the 5x equals 400 divided by 5 is 80. Now I can change to logarithmic form. So log base 2 of 80 equals the exponent, which is 5x. All right, and then we're gonna, that's one way we're gonna write it. The second way we're gonna write it is to set the 5x equal to the change of base. So log base 80, I'm sorry, log 80, that's base 10, over log 2. Log base 10 of 80 over log base 10 of 2. Log 80 divided by log 2. All right, 6.322. There should be an equal sign here. So 5x equals 6.322. I'm going to divide each side by 5. And we get 1.2 1.264. Notice how I left the value on my calculator and then divided by 5 in order to get the most accurate answer. So x is 1.264. All right, next one, log. My base is that number that's being raised to an exponent. Log base 7 of your answer equals your exponent. And right now my exponent is x plus 2. We're going to rewrite this as log of 32 over log of 7. And then we're going to do log of 32 divided by log of 7. And at the end, we're going to subtract it by 2 because I'm going to move this 2 to the other side. So you get 1.781 equals x plus 2. Then we subtracted the 2 to the other side. Please make sure you do that on a calculator, or you show the proper decimal places. It'd be 1.781 minus 2.0. So you get negative 0.219 equals x. I'm going to write that again. Normally we don't like the negative numbers when we're talking about logs, but a couple different things. A log, x can be a negative exponent. It just can't be a negative value for one of these, the 7 or the 32. Also, if I plug in that negative number, it's going to give me a positive exponent anyway when I add 2 to it. It gives me 1.71. All right. Got 4 more. Solve for x. Write your answer in terms of a logarithm, so either a logarithm. Then evaluate your answer using a scientific calculator and round to the thousandths place. So same thing as the other side. Remember, we're going to get rid of anything that's extra. All we want on the left-hand side is our base raised to the exponent. 15 minus 2 is 13. So all I did was subtract 2 from each side there. We're going to change to logarithm form. So log base 10 of 4x. Nope, sorry. Has to equal our exponent at the end. Log base 10 of 13 equals 4x. So something cool right now. Log base 10 of 13 is just log of 13. You don't have to change the base on this problem. So if you solve for x, you can divide by 4, and you get x equals log of 13 divided by 4. So log of 13 is the same as log base 10 of 13. You do not have to change the base on this problem. All right, and then we can divide that by 4. And we get x is approximately 0.278. All right, last problem. We're going to get rid of that extra 3 that's out in front because the base is e and the exponent is x minus 4, which means we can divide each side by 3. So e to the x minus 4 equals 7. Now we can change into logarithm form. Remember, natural log is base e of 7 equals x minus 4. We can add that 4 to the other side. Do not add the 7 and the 4. This is the natural log base e of 7 plus 4 after. Then if you were to show this properly on the calculator, you would have parentheses around that 7 because you're only taking the natural log of the of the 7, not the 4 as well. And you can take a natural log on your calculator as well. Right under the log button, you should have a natural log or an ln. You can do ln of 7. You don't have to write the e down. Close the parentheses before you add 4, or you can take ln of 7 and then add 4 later. We get 5.946. So x is approximately 5.946. All right. Now, these equations we're going to solve for y in terms of x. So solve for y means you want y equals something. Y equals something. So this problem on the left, we are going to subtract 7 because we want to isolate y as much as we can. So we get 10 to the 3y minus 1 equals x to the third minus 7. Then we want to get y down. Get it down from the numerator. So we take log base 10 of our answer equals our exponent. Answer is the right hand side, exponent comes from over there. Still solving for y. We're going to add 1 to the other side. That does not go inside those parentheses, so log base 10 of x cubed minus 7, parentheses, plus 1, equals 3y. So now all we have to do to solve for y is divide by 3. Log base 10 of x cubed minus 7 plus 1 all over 3. Now those are pretty advanced problems down here. So I want you to try this last one on your own and see what you get. If you can get that one, then you're doing really well.